Good morning, good afternoon, good day, wherever you might be in the world. Thank you for joining our live webinar today. My name is Andy Walton. I am the Vice President of Technical Sales for Densify, and we are moving here already. And welcome to our webinar on cost control, visibility, and automation in Azure IaaS environments. Today, I'm going to take you through a few slides to level set, and then the demonstration is going to focus on Azure, right-sizing recommendations, IaaS environments. We're going to get into some automation with Terraform, and I'm going to show you how we present and slice and dice and show anomaly detection of your Azure bill. First off, for those that don't know, we are hybrid resource optimization and control. We provide enterprise class resource analytics and control over cloud, container, and VMware infrastructure. Specific to VMware, the key to our sweet science is really the placements and our predictive analytics to help us place and manage workloads in a way that increase density while reducing risk. Part of that placement algorithm really helps to do the software license cost optimization, so control your host or core-based licenses, or capacity management there, and really the whole game is to drive up density safely without introducing performance risks. Our focus today is, although we focus on AWS and IBM Cloud and Google Cloud, is really on Microsoft Azure. In this area, we're reducing costs, really helping companies determine what's the best match of application demand versus the correct supply running in the Azure cloud. Improve your purchasing of the right instances, cross-charging and reporting, and of course, we'll also demonstrate automation of these detailed recommendations through your CI/CD framework. Finally, on the container side, Kubernetes, it's really all around, first off, just getting visibility and observability on what you have running in your environment today. But making recommendations to enable cross-charging, reporting, and then taking those recommendations for right-sizing the resources running against your containers and the nodes above those, and automating those recommendation decisions much the same way as we will show today with Azure. What matters most in Azure cloud optimization when we talk to our customers is really helping them determine what's the right type and quantity of resources to buy, making sure that they are not being wasteful in their purchase decisions, while making sure that they do have the right amount of resources to ensure performance. That precision and being able to really rely on the recommendations, we're going to get into something called the impact analysis report, app owner reports, that provides the detailed precision that can be actioned. People will take advantage of that information so that it's the evidence they need to actually be able to rely on the details that we provide. And then being able to automate those recommendations, which of course, we've mentioned that. Okay, how does Densify work? So at the heart of our patented analytics engine, it's the thing that drives all the answers. There's a number of inputs. Some of the inputs would include the application demand patterns. So essentially what Densify does is it takes historical data and learns from the past in order to predict the future. So we'll take the application demand patterns, CPU, memory, disk, network IO. We'll take that information agentlessly from the cloud native provider. In the case of Azure, it's simply an API call using subscription IDs. So we'll pull that information in, and we'll understand what's gone on in the past, and we'll build a predictive 24-hour model for each individual workload, each metric that we capture. We augment that with the infrastructure characteristics. So as an example of performance benchmarks, we use third-party benchmarks. That allows us to essentially provide an apples-to-apples comparison as we look at workloads running on one platform, say on-prem, versus what's running up in the cloud. Take that information and then be able to normalize that across different platforms. We add into that technical rules and efforts. We understand certain types of infrastructure might have different hypervisors, different storage, different network types. And taking that and being able to understand, is this a recommendation that will bend the laws of nature? Is it something that we can actually implement, or is it something that's very difficult or possibly impossible to do? So the rules and recommendations are informed by this information. Pull in business and functional tags. You'll see that in the demonstration as well, understanding what infrastructure belongs to who, not only just from a reporting perspective, but also being able to treat those workloads differently. So fit for purpose policies that help us say, okay, a production workload is treated differently than say a test dev or a staging workload, or certain application types or infrastructure that belongs to different business units. The fit for purpose policy engine enables us to have very customized and detailed recommendations based on how those applications need to be treated. Some obviously more sensitive to risk than others. All these inputs basically come into outputs. So what sort of things do we do with all these answers? Number one in the focus today is the cloud resource optimization. So matching the application demand with the correct amount of supply, making sure you're not being wasteful while not introducing performance risks. The virtual environments and container optimization is really all around playing Tetris with the workloads. Once we've built a predictive model, there's ways to squeeze those workloads together onto nodes for the containers or onto hosts, VMware hosts that are running the different workloads in a way that increases the white space, predictably packs things together so we increase the ratio of VMs to the hosts. Migration optimization types of analytics. So if you're moving workloads to the cloud instead of lifting and shifting, understanding what exactly that resource needs or what it's been using, and then actually purchasing the correct amount in the cloud. If you're moving, on-prem up to the cloud or cloud to cloud, refresh types of optimization. If you're doing server refreshes on-prem, that kind of analytic is what we call migration optimization. Of course, that's a big thing for many of our customers today. And purchase optimization, reserved instances, and savings plans in the AWS world, making sure that you're buying the right stuff if you're going to lock in longer term. What do we do with these answers? The answers are provided to people or reports through a detailed reporting engine. We have Jaspersoft built into the product ourselves. Many of our customers will leverage their existing enterprise tools like a Looker or Tableau or Power BI and build detailed reports so that that information can be transferred to the right people without them having to actually learn or use an interface. Simply, they get reports. Many of the recommendations will have to be actioned and approved. So integrations into ITSM ticketing systems like ServiceNow or Jira for closed loop approval automation of a recommendation. Once it's made, someone gets approval action on that, approves it, and then the change can be made. We'll talk a little bit more about that in the automation section. Collaboration side. So if you're using Teams or Slack, living in that interface, subscribing to applications, looking for new recommendations, being able to review them and approve them directly within those types of collaboration teams. And then, of course, automation APIs, infrastructure as code, so the whole CI/CD framework. Today, I'm going to talk about Terraform. We've got integrations to basically any of these types of systems will accept our integrations, simply API calls that they have to make. And we'll talk a little bit about what that looks like a little further on. So essentially, that is the recommendation engine in one slide. I mentioned we're also going to talk about cloud cost intelligence, so deep bill visibility and reporting for Azure environments. So monitoring, understanding the details associated with your Azure bill, detailed reporting and filtering and understanding which lines of business are using which services, and chewing up components of your bill on a month-to-month basis. One of the new things we've produced is something called anomaly detection. So I've got some nice examples in there on how we actually use that to detect strange trends that will lead you to find folks that are overspending or potentially have discovered ways of underspending. And we'll talk a little bit more about that. In the optimization as code, I've talked about this integration into the different tooling systems. This is an example of Azure here. So this is it's an Azure instance running in Terraform. A lot of times these folks, the operations, engineering, whoever's in charge of actually setting this stuff up, really doesn't have that much of an idea of what they should be buying. So these hard-coded instances or templates that show, hey, I want to buy a standard D2 or whatever, because that's the one I always buy, it's my favorite, or whatever it might be, tribal knowledge or the way it's always been done. These micro purchases really are like purchasing as code. So you do this 10 or 100 or 1,000 times, and you're now overcommitting resources in a lot of ways just because that's the way it's always been done. We think there's a better way to do that, actually, and that's to replace that hard-coded template with an actual call into Densify, saying instead of a hard-coded guest, to call up Densify and saying, based on the machine learning, the predictive analytics, it's going to tell you what that instance size should be. And so we call this CI/CD CO, continuous optimization. As that workload pattern changes, this call into Densify will always ensure that this thing is sized correctly. So forever optimized, essentially. What does that framework look like? And the last slide before I get into the demonstration here, but essentially, you've got all the different public or private clouds, VMware, AWS, Azure, etc. Densify, through its analytics, will collect that data. Again, it's an agentless process. We'll optimize, analyze, make recommendations. First piece in a lot of cases is the round trip approval with a business owner that has to look at that change and say whether or not they're willing to make it. So sometimes it's manual, a lot of times it's automated. One of the key things in this type of analysis is the Densify visibility reports. We call them impact analysis reports. Or an app owner report, essentially, which is the gory details of exactly what we're going to do to that instance in order to make it run better or potentially be a little cheaper, but while still staying within the parameters of that policy engine. So I'm going to show you an example of that a little bit further along. That's a detailed evidence that an app owner needs to make a change. And that's one of the big differences between ourselves and, say, some of the simple bill readers out there that will maybe recommend a change based on a savings of, say, $30, $40 a month. The reality is that it's a black box. You don't really know why it's being made or what's going to do to the instance. This is the evidence that these folks need in order to be comfortable that their application is going to stay up. After this, the insights will go into some kind of systemized or centralized system of record. That could be some kind of SQL database. In the AWS world, that could be something like a parameter store. Essentially, the record and the history of the changes would be pushed somewhere. Based on, we're making an approval, who's doing that, and what's the instance size, and how's it changing over time, etc. And then from there, we'll automatically trigger the correct implementation mechanism. So whatever declarative language you might be using, again, in this case, we're going to show Terraform, but it could be something like Ansible or Puppet. So basically being able to call that infrastructure and those tools that you're using in your environment today. Even if you're running instances and you don't have anything that's controlling those, no Terraform templates or CloudFormation, what have you, there are ways as well that we can integrate into things like some of the serverless infrastructure like AWS Lambda or other serverless infrastructure services that will allow us to actually make these changes for even instances that are not being controlled by the IAC stuff. And finally, this is how we get this whole automated optimization. Anyhow, enough of my yakking. Let's get into an actual demonstration and show some of these recommendations live. And by the way, the Terraform integration, and I'm going to show you here, you can click on this link for HashiCorp, and that will take you to the website, and you can get into the gory details of what those integrations look like. Okay. So the first time you log in to the Densify instance, you will get information on your instances and your services. In this case, I'm actually running cross-platform. So this is all the services I'm running: EC2, RDS, and autoscale groups in AWS, and virtual machines and Compute Engine from Google. So it gives me a high-level summary as to how well I'm doing. Let's drill into Azure right away, because that's what we're focused on here today. So first, drill in. It doesn't look like I've got a lot of infrastructure running here, but the reality is I actually have set up a filter already. So again, those tags come in handy when we want to drill in and just look at the infrastructure that we care about. In this case, I'm looking at something called a mobile automation business unit. Again, I could use any of these tags in different areas and drop downs to apply filters to drill in. So everywhere across the Densify interface, you'll find basically a status as to how well you're doing. So when we analyze the workloads, we found one here that's at risk, and we have 3 savings opportunities. It will show us the how we're doing over time, resource allocations, predicted before and after utilization. Down here, the details, we're going to drill into these things here. So we've got 1 at risk, 3 savings opportunities, and then a summary basically across the environment as to what's the aggregate as well, savings or additional money that needs to be spent. I'm going to drill into these 4 systems. And so here they are. I'm just going to refer to them by the last 3 numbers just to make things easy. I've got a terminate recommendation for 178, basically means that workload's flatlined. I've got a downsize recommendation. That means that I could use a less expensive type, so going from different general purpose types of workload environments here from one to the next. So I'm staying within the same family. There's another one here called 525. That's a downsize optimal family. So basically it means we're going to change families in order to, again, better match that application demand with the current workload. Let's focus on 2 of them. Let's start with 171, which is an upsize recommendation. we're moving from a general purpose to compute optimized here, because essentially we've breached a policy around CPU. CPU busiest day has actually exceeded the policy, and on the predicted day as well. Software will give us an indication of how long something has been running for, what is the current cost and the estimated cost based on what we're recommending. In this case, it's an upsize, it's going to cost us a little bit more. Something called an effort level, which again I called out earlier, saying software is fully informed on the differences between these instances, so it won't make a recommendation that you can't apply. They might be running a reserved instance against something, or whether or not it's got different storage or network capabilities or different hypervisor, and that information is highlighted inside these effort details here. In this case, it's low effort level because there's not a lot of difference between these two, so it looks like something that we can actually implement from an automation perspective. And then a bunch of different more details around the differences between those instances, CPU, benchmarks, etc. The most interesting part is the actual workload pattern. So again, this is the predicted 24-hour window for every metric in this instance. We're looking at the peak, the sustained, the average utilization for every hour of the day, and building out this view as to what this thing is going to do on a daily basis. So what you've seen here is the before and after. So the blue represents what we're predicting CPU looks like on a typical predicted day, and what it will look like after in the green. Now, over the history that we have based on the policy, you might be looking at, say, the last 60, 90 days. This is what it looked like on its busiest day, so it's breaching its policy limit. And this is what we're going to do when we move this to the compute optimize. It's going to bring that workload curve down. And then every other metric that we have is captured in here, whether it be CPU, memory, network, disk I/O. We can augment this for the load from something like Datadog or Splunk, SignalFX, wherever it's coming from. We can augment this data. The more data we have, the better the analytic, and the better the answers will be. And then we have another recommendation here for downsize optimal family. Similar kinds of things here. We're moving from a DS3 to an E2S. Before and after, you can see that right now that we're well below the predicted workload pattern on the predicted day. And so when we move to this particular instance, it's going to be a little bit cheaper on different instance family. The predicted workload curve is going to be a little bit higher. We're going to sweat the assets a little bit more here that we're spending. Same thing on the busiest day, but still well within the policy limit that we've defined. And you get the idea, I'm sure. This is really the difference, is this level of prediction and this level of analysis, as opposed to saying, well, your average utilization over the last 60 days was 8%, which can be very dangerous type of metric. If you're just really flattening everything out and looking at average or peak, you're either going to be introducing wildly conservative recommendations or dangerous recommendations doing something like that. Okay, well, I'm about ready to actually make some changes to my infrastructure here. I just wanted to let you see that I'm actually running this. Here's my Azure window right now. So actually there's 171 and 525. They're actually running up in Azure right now. Actually, I've got them stopped. So those are the current instance sizes. You'll notice that they've got current and they've got tags on them as well as what their optimal instance size should be. So this is part of the integration. We send some tags against these instances just to give us a little bit more information. What I'm going to do is I'm going to move to the approvals button. Again, I'm going to simulate the use of, say, an ITSM or Slack for this particular instance. And I'm just going to use the simple approval mechanism that we have built into Densify to say, well, let's approve this particular change. And we're going to move that to the standard E2S. And for 171, we're going to do the same thing. We're going to approve that change. And you'll notice that the policy also controls what you actually can do. So you might say, I want to optimize if I have certain types of recommendation, modernize or move to an optimal family or a downsize. But for terminate, I don't want to automate that recommendation. So again, that's all controlled by the policy as to who can do this. And I'm just showing a very simple example within the interface here. Typically in an enterprise type of deployment, you'd be using full ITSM system here. Okay, I've set my approvals. I'm going to move into a program I have. I've got Terraform running in this particular window. And this little program here is a Densify Terraform integration. Basically, it allows me to inquire against Densify, against the approvals that are there, and then essentially act as the updater for that centralized parameter store, which is in this case just a Terraform variables file. So I'm going to check to see if I have any recommendations, and I should have a couple, because I just approved those things. So let's see what we've got here. There they are. So there's my two recommendations in the system for 525 and 171. See the recommended type and the current type. So I'm actually going to update my Terraforms file. And then I'm going to actually go and implement this change. Now again, I'm doing this live. Typically you would do this as part of a scheduled basis and an overnight type of hours. So I'm just type in Terraform apply. And this usually takes a moment to get moving here. So we'll just wait for that to happen. Again, this would normally happen in an overnight type of hour in some sort of a period because it does require a very brief outage for the instances, whether you're using Azure, any of the public clouds actually will have a similar type of behavior. So refreshing the state should come through and actually see that there are some changes that have been detected based on the updated variables file. And we're almost there. Always fun. There we go. So there's the two changes. It says, do I want to actually change this? Yes. And you can see this is somewhat manual. Of course, this would all be automated. And so as I change that, let's go back to my interface. And let's look at, you can see that these instances are stopped currently. If I refresh them, I should now see that they have actually been sized with their optimal instance type. So 171 is now the F4S and 525 is an E2S. So we've upsized the one, we've downsized the optimal family on the other. So let's keep an eye on the clock here and make sure we get everyone out of here within the half hour. What I'd like to do actually now is just do a brief review of Azure, the Cost Navigator. So there are Cloud Cost Intelligence module now available with Azure environments. So you can see right now, I'm looking at a brief period. It looks like the last quarter, or at least late last year in 2019. I've got this broken out by regions, so you can get an idea exactly, you know, where most of the money is actually being spent in Eastern US. So we've got all these different bells and whistles where we can pick and choose what it is we want to group by. Quite often, you want to look at service. So slice this this bill in a slightly different way and look at where we're spending the money, which services we're actually running on, which is of course interesting as well. All those tags that I'd mentioned earlier are useful, so we'll pull in anything that you actually have set in the public cloud, whether it be for things like application, business unit. If you've got your own custom tags, we can actually customize this interface or configure it, as it were, to show up whatever important tags that you want to see. So I could pick, you know, 1, 2, 3, say apply, and my interface will actually be broken or at least refreshed based on the business units and who's spending what in those areas. And then of course we have a tabular view. So underneath the covers is the details of all the specific, you know, day by day spend or hour by hour spend, depending on how you're collecting that data. And in this case, broken out by individual days and individual services. So as we see on a day-by-day basis, broken up for these 3 business units. So the last thing I'm actually going to do now is actually, let's have a look at the outliers. The outliers are a really important part of analyzing the bill because, of course, slicing and dicing all this information and being able to provide it to different Power BI tools and things. Sometimes some of our customers will use this. Some of our customers will actually export and use our, you know, different formats, or being able to export this data into a form that they want to use, and then just whatever tool that they're comfortable with. So that's all available as well. The outliers native to the product, really important part. So in this case, I've broken out, I'm still looking at services on a daily basis. So it should detect a few things here and there. And this isn't a monstrous bill by any means, but this should serve the purpose. So on a couple days late in October, I've got some storage issues, and I also have a SQL database where our delta is either above or below. So let's just click on the first one here, saying that I noticed something that's 80% different than you normally would see. Let this load up. And what you're going to see is basically broken out. In the middle line is your average spend. The blue lines represent, in this case, 2 standard deviations. And of course, this is all configurable in terms of what you want to analyze. Is it 2 standard configurations? How many days do you want to go back or include in your period? As well as, is there a minimum amount of spend? Like, I don't want to see anything unless it's $500 or more, as an example. So what's interesting is we've detected 3 anomalies. There they are, right there where we've gone outside that second standard deviation. And then the details on the previous window, you'd be able to drill in and see exactly what happened on that day and what was the difference in the spend. Now what's interesting is one of our customers recently found one. It wasn't the overspend, though, it was underspend. It was a database service running in the public cloud. And they noticed that it was well below the second standard deviation there. So what's going on? They checked in and found that some of the folks that were setting that infrastructure up had found a different way to configure it. And the way they were configuring it was significantly cheaper. And so by discovering the anomaly, they're actually able to change, standardize the way they were configuring those databases. And actually that resulted in tens of thousands of dollars a month in savings on this particular service. So just an idea that the outliers aren't just to detect folks that are actually overspending. It's also to find interesting trends like that where you might be able to save a bunch of money. Okay, let's wrap up. And again, if there's questions, please use the interface through the meeting here to ask questions. So let's go back and say, if you're interested in seeing this for yourself with your own data, we offer 14-day trials. Essentially, go to our website, densify.com. There's a button right in the upper right that says Start My Trial. Click on that, fill out some information, just a little bit of information about yourself. We'll contact you and understand what it is you're trying to do, what environments, etc. And typically after that conversation, within 15 minutes, we can spin up your own instance where you'll collect your data. And it's really simple to actually get this going. There's no agents to install. It's basically uses existing read-only credentials, and we'll pull the data. By default, we'll typically get 60 days of data from your accounts, and then within a few days, we have a pretty good understanding of exactly what's going on in your environment. And so let me have a look at the interface here and see if there are any questions. There was one question about, where did it go? There was a question around how do you actually predict with your infrastructure as code how big something should be based on the fact that it just started up, you don't have any history. I'm paraphrasing here right now, just looking for my question, but I saw that pop through a little earlier. The idea there is that you can set a fallback workload. So we don't have enough, if the policy says I need a certain amount of data to actually be able to make a recommendation, then I'm going to wait for that. And then you can actually set a fallback workload type. Maybe it's the default one you wanted to set before, but it will set that correctly. And once the system has enough data to actually make a prediction, then those predictions would kick in. What else do we have? How much history does your analytics require before it makes a recommendation? That's a good question. It's really configurable, and it really depends on the workload type. So for a test dev environment, maybe 7 days is enough for you. In a lot of cases, that's perfect for a test dev environment. If it's some sort of a business or trading system or whatever, maybe we have to capture some sort of a peak period. That could be a month end, it could be a quarter end. Some cases, maybe it's a year end. Or some sort of peak period during the year. So it really depends. If we're detecting risk, we really only need 24 hours worth of data. If something's gone wrong, then you really can detect that right off the bat. So if something's wrong right now, we only need 24 hours to see that. If you're going to actually make downsizing decisions, typically someone wants to make sure they're comfortable with that. What else? Do you support other configuration infrastructure as code tools? We are using Ansible. Yes. So in that one slide I actually presented, I used Terraform as the example today. In AWS environments, we see CloudFormation all the time. We have customers using Ansible. So really, any sort of configuration management infrastructure as code tool that will accept, say, an API call in there. So that's basically what you're doing is calling Densify. We can support any of those things. Not seeing any more questions right now. Give you another minute or so. while I'm waiting to see what else we might have, I just wanted to remind folks that we do have some upcoming webinars. So go back in. If you got on this one, you know the process. Just go to our website, check the events. May 27th, we're doing a webinar on AWS optimization, deconstructing different instance types. They're always coming out with new ones. And so we're going to talk about that and our capabilities via analytics. On June 17th, we're going to dig in a little deeper and talk about automation at scale in the cloud, a little bit more details on what we're doing here. Probably talk about some cloud formation and some parameter store in that one as well. And then finally in July, that's a long ways away, just getting into spring here. But anyhow, it's not, I guess it's not going to be that long. Anyhow, we're going to talk a little bit about AWS savings plans versus reserved instances. We still see a lot of questions, still some confusion out there as to what they should be doing. By default, looks like savings plans, but there's cases where reserved instances still make sense for some customers, some places. So we're going to talk about that. I don't see any more questions here, so I'm going to wrap it up. I really appreciate you folks coming here today and spending time with me. We look forward to seeing you on the 27th. Have a great day and stay safe. Cheers. Have a good day.